Well, we have a nice loop that is making 30 steps. It is starting from 0, increasing the counter before 30 and stopping when 30 is reached. And we are making one step at a time. So really 30 times we get a new value for next number, but this new value is always the sum of the previous and current values, 1 and 1. Those are the numbers that we should change. So what we have to write is, for example, current number to be equal to next number. So we are preparing for the next step. And previous number to be equal to current number. Do you think this is going to be working fine? Let's see and test it. I'm going to press a key now, and this seems interesting. Do you see here well? Well, if you take a good look at those numbers, you will see that always the previous and the current number are the same. So this is not really good, and we get a different sequence. If you are good at maths, you will know that those are the numbers that are powers of 2. So this is 2, and this is 2 multiplied by 2, and this is 2 multiplied by 2 multiplied by 2, or 2 cubed, and this is 2 on a 4th power, 5th power, 6th power. This is not what we wanted, and we should be really careful at what is going on with our current number and next number. So current number is getting its good value from next number, but then this value from current number is immediately sent to previous number. So actually what's wrong is previous number. In this moment we didn't want to get 4 as a sum of 2 plus 2, but we wanted to add 2 plus 1 to get 3. So this is kind of strange problem, and I'm going to solve it in a much stranger way. I'm going to take this line of code and place it here, so that in the beginning we get a new value for previous number, the current value, the current number, and when we are ready with this old value of current number, we will then get a new value for current number. We will get it from next number. So let's see what is going on now. This looks much better. And yes, in one moment the numbers are, the next will be 89, and the previous two are 34, and the current is 55. And in the next step, 55 is now the previous number, 89 is the current number, and from them we get 154 as the next number. So perhaps this is the 30th number of the Fibonacci sequence. You should be really careful with such sequences that increase so fast, because if I wanted to get not the 30th number, but for example the 100th number of this sequence, you will notice that the numbers increase much faster and faster. And you will notice one more thing. Apparently the computer stops evaluating really fine, because on this step we are trying to add a number that ends with 0 to a number that ends by 4, and the result isn't a number that ends with a 0, it's a number that should end with a 4 or something like this. What is really going on is that the variables that we use cannot fit such a huge numbers, and in some moments the JavaScript code is not going to be executed really well. You should be careful with the huge numbers. We don't have a problem for the first 30 or 50 numbers, but really soon we have a problem for really huge numbers, like the 100th number of a Fibonacci sequence and even the perhaps 80 number. I think those are the last 20 numbers and they aren't evaluated correctly, but perhaps the first 70 or 80 numbers are correct. I hope you liked this mathematical task. If you like such a tasks, and for example you are okay with making not only games but ugly programs that evaluate something, I will advise you to also learn C++ programming. There are a lot of algorithmic competitions that use a program like CodeBlocks or other C++ editor to write ugly black and white programs that just ask the user for some input and evaluate something and output it. If you like such tasks, you will be able to win a lot of algorithmic competitions, and this is an interesting alternative to game programming. But now I will stop talk about this, and I'm going to go back to tasks 3 and 4 from our last homework. Today we are going to make a game with a lot of enemies. It's our first game that is going to have not copy-pasted enemies, but enemies that use the for loop. If you are already completed those two tasks from your homework, perhaps the next minutes in which I'm going to explain them are going to be boring for you, but I think that you should watch them anyway. Perhaps I'm going to do something a little bit different from what you have done in your homework, or perhaps you've made some mistake in those two tasks. So let me start now, and let's go to our previous code with I'm closing Fibonacci evaluations, and I'm starting with our code with health bar that we used a for loop for it. We also made jumps in our game that are executed when we hold the space bar. This was the last of the modes that we made. And I will be much happier if we don't have just one enemy, but for example 6 or more enemies coming from right to left. For such a task, I'm going to change the idea of enemy X, because we are not going to have just one enemy but a lot of enemies. So I'm going to copy this variable's name and I'm going to replace it in all its occurrences. I'm going to replace it with enemies X. So I'm going to change enemy X to enemies X on all of the occurrences. And I'm going to make one more change. I'm going to change enemy Y to not check for a specific one enemy in the arc lighting in update, and not to draw for only one enemy, but instead to loop with a for all the collision checks and to loop with a 4 for all of the drawings of an enemy. This is your task now. Instead of using one enemy's X, use enemy's X, and instead of using enemy Y that looks like it's working for only one of the enemies, instead of it, use current enemy Y, that is going to draw all our enemies at different Y's and is going to check for collision with all of our enemies. Good luck!